Okay, let's look at the general algebra. So you'll be you're required to, this is section 2 of the question paper. So when they ask you to expand, they basically say multiply out. So the x multiplies this x, it's going to be x squared. The x multiplies the 3, so it's going to be a positive 3x. And then when I look at this negative 5, the negative 5 is going to multiply the x, so it's negative 5x. Then the negative 5 also multiplies the 3, you get a negative 15. So my answer here, I don't have any like term for x squared. So positive 3x being negative 5x giving me a negative 2x. Then there's the minus 15. Now, getting to the second question, guys, these are common errors that you guys make. Do not say this, then the answer is a over 1. No. Don't do that. Don't do that. Instead, this is what you should do. You have something that is common. Always look for a common thing. There's something common about things. So look at here. You have two terms. You have A, B, then you have A. It means that there's something appearing on both terms, which is what? It's A. So I have A being a common thing. What remains there? It's B plus a 1. Right. So careful of that. Instead of saying 1, you say A. Remember that when you take out a common factor, right? So I have AB plus A. If I'm taking out a common factor, I'm saying that A is a common factor, right? So it's going to be AB divided by A plus A divided by A, which is a common factor, right? B plus 1. Good. So this is going to be all over AB. And now, because there's multiplication here, there's multiplication, this can eliminate that. Then my answer can be B plus 1 all over A. So all over B, all over B. The B doesn't cancel. It doesn't come. I know you like canceling. You like doing this. No, that's incorrect. Then now I look at the second question. They are saying I should factorize. When they ask you to factorize, always look for the common factor. Like before difference of two squares and cubes and everything, look for the common factor first. What is common for 8k squared and negative 2? Positive 2. 2, then I'm going to have 8k squared divided by 2, it's 4k squared, minus negative 2 divided by the 2, it's a 1. Now I have a difference of 2 squares inside it, right? So I'm going to have 2, then difference of 2 squares, it's 2k minus 1, then 2k with a different sign. Square root of 4k squared is 2k. Square root of 1 is 1. So that's what I have there for factorization. And then let's get to a trinomial. Right, so I look at the factors of 12 that are going to give me a negative 7. 2 and 6, most likely I'm not going to get it. 7. 1 and 12, no. But 4 and 3. With 4 and 3, I know I can get 7, right? So I already know that I have x here, and then I have x. So this is with negative 4. This is a negative 3. Because negatives and negatives are going to give me the 7 here. Okay, so getting to the next question. Again, we are required to factorize. Remember, look for the common thing. In the numerator, we have something common. X is common. So for both ones, I can factor it out. But please, again, I know, some of you are quick. Don't do that. Don't do that. Don't do that. There's a positive and a negative, not multiplication. You cannot do the elimination things. Don't do that. Don't create. I know you are God, a God, and okay, you know what? Let me see. Let's not even go there. X plus 2 all over. This can be factorized as a difference of two squares. X squared is a perfect square and 4 is a perfect square. So I have x minus 2, x plus 2. 2 represents the square root of 4. Now I can do the cancelling. There's x plus 2 and x plus 2. The answer is x all over x minus 2. Remember, there's a negative sign separating the terms, so you can't cancel. You cannot do that thing. Cannot. Oh, there's your final answer. And then let us get to the next question. Question 3. Solve for the unknown. Okay, the unknown seems to be x. Like they could have just said solve for x. I mean, but it's fine. Take everything that is a variable to the right. So I'm gonna have 3x. Then when I take this side, it's going to be minus x. Then equal to, take that side, it's 6 minus 4. It was a negative, now it's a positive. And then I solve this. This is 2x equal to 2. So I divide by the 2. I'm dividing by 2 because I want to cancel the 2. So the x is equal to 1. Guys, 2 over 2 equals 1. A over A. It's not equal to A. Don't do, no, please don't do those things. It's not equal to 1. Instead, it's equal to 1. A number divided by itself is 1. 1 million squared is 1. Number divided by itself. They have to be the same. Then it's gonna give you 1. Now, getting to the second one, you have 3a exponent a equal to, stop saying also 3. Don't say 3 to the power a. Power. This thing here, it's called a power. That's what's called. It's made up of a base and an exponent. So you say 3 exponent something, 3 exponent a, not power. Of 10 powers. Good. Good. So I have 3 exponent a. Then I can change this number in power form. 81. See what I can do. 81, I can say, this is what I do to the calculator. 81, then equal to, right? Then I say shift, I go to a factor. There's a button that shows facts. It is, where is it? Considered button now. Okay, but anyway, that button, you're gonna find it. That's gonna give you like the factors, the prime factor of 81. So it's going to be 3 exponent 4. Right, so now I have powers of the same base. You see, powers of the same base. So I equate the exponent. A is going to be equal to 4. If you have powers of the same base, you equate. This is like having 3 exponent x be equal to 3 exponent 4. X is equal to 4, right? Powers of the same base, add the exponent. B exponent c equal to b exponent 5. Powers of the same base, c is going to be equal to 5. Yes. Powers of the same base, you equate. Sure. And then now here I just take the solutions. Right. So when I have something like this, I have x minus 1 being equal to 0, or x plus 3 equal to 0. So I'm going to say x is equal to 1 and x is equal to -3. Then looking at this one here, again, 64, 4. There's something common there. 4, I know 4, it's a factor for 64. So I have 4 outside, then this is m squared minus something. 64 divided by 4 parts, 16. So difference of two squares again, I'm not done. I have m minus 4, m plus 4. There we go.